This is Algebra 1, Lesson 29A, Negative Exponents, examples 29.1 through 29.5. If you didn't watch the video right before this, Algebra 1, Lesson 29, and it said, please watch this first, you might want to go back because this is going to base off of that video. Now, we learned in that video that when we have a negative exponent, that gives us a fraction. And so we do that based on that negative exponent. And then the denominator is going to be 5 to that positive exponent. So 5 squared, which is 1 over 25. Now, your book shows you a different way to think about it that doesn't explain why it works like we talked about in the previous video, but it gives you kind of a little bit of a shortcut. So let's talk about that. Here, when it's written as 5 to the negative 2, and then you change it almost into a reciprocal form, a 1 over form. If it's 5 to the negative 2, then we can switch that 5 down to the denominator if we make the exponent positive. So it went from being 5 to the negative 2 to 1 over 5 to the positive 2. So with that kind of thinking, you could also go backwards. If it's 5 squared in the denominator, it can come back out and up to the numerator if it has a negative, okay? Now again, the last video explains the why, but this is a little kind of a trick that you can use to rewrite it. So here, if you've got a negative exponent in the denominator, it's going to come out, okay, and be the opposite. So it'll come into the numerator and have the opposite sign, which would be a positive. So this is just going to equal 5 squared, which is 25. Now I want to take the time to show you this longhand, 1 over 5 to the negative 2, based on what we said in the last video. That's the same as 1 over, and then 5 to the negative 2 is a fraction, 1 over 5 squared. So we have 1 over 25. What does that mean? 1 over, let's rewrite that as 1 divided by. So 1 divided by, that's this 1 over 1/25. Let's keep change flip. That's going to be equal to 1 times 25 over 1, which is going to be equal to 25. Now, arithmetic-wise, that was a lot of work to show where we got it. But based on this understanding, we can go straight from this to this. But if you weren't convinced, here's your convincing of the arithmetic. So they generalize it and they say, well, what does this mean? All right, a definition of a negative exponent in this book says, if n, meaning the exponent, is any real number, and x is any real number that isn't 0. This is not going to work for 0. Can you think of why? Well, put a 0 here. Do you see that 0 in the denominator? And we know that's undefined. That's why we can't have a 0 in the denominator. So if that all is true, then 1 over x to the n would be the same as x to the opposite of n. Just meaning if you have a power in the denominator, you can bring that power out into the numerator if you take the opposite sign of its exponent. And that's what they did here. So that's generalizing the rule we just tried. So let's practice that a little bit. Here we want to take this 3 out. Its exponent is 4, so let's make it a negative 4. Okay? Here we want to take the 7, and we're going to put it in, because again, we just keep flip-flopping back from the different form. Both of these are equivalent. So here, this one's not written in a fraction form. Let's put it in fraction form. That negative 2 then would be a positive 2, which would equal 1 over 49. Okay? And then C, we have 5 in that denominator. Let's bring it out. Sign, change that sign. Opposite, it's going to be to the 8th. I'm not going to work that one out. All right, and then 6 here, let's write it as a fraction. So that's going to be 1 over the 6. And instead of to a negative 3, it would be to a positive 3. So using that, they go ahead and they summarize it a little more, and they say a number or a variable that is written as an exponential expression can be written in reciprocal form or as a fraction if the sign of the if the sign of the exponent is changed. So let's go back through that. A number or a variable that is written as an exponential expression. Here's your exponential expression. It can be written in reciprocal form if the sign of the exponent is changed. And you can see that here. Exponential, and this is reciprocal form, sign of the exponent is changed. Here's your exponential, reciprocal form, sign of the exponent is changed. Here's your exponential, and this is your reciprocal form, and the sign of the exponent has changed. If the exponent is positive, the exponent is negative in the reciprocal form. And we saw that. If the exponent is negative, the exponent is positive in the reciprocal form. So you can flip-flop it. All right, again, it's not addressing the y, but it's telling you a quick way to handle it with the arithmetic. So let's do this. A couple different ways you can think of it. We know it's going to be a fraction, and that's going to be over 3 squared, right? Or you can think about it with the rule we just used. And we say if we want it in reciprocal form, we could put the 3 in the denominator, change the sign of the exponent, and then that's just going to be 1 over 3 times 3, which is 9. So 29(1) is 1/9. Let's look at 29(2). This is written in reciprocal form. We can change it to exponential form. So what we're going to do is we'll bring the 3 out, and we'll change the sign of the exponent. So that's going to be equal to 3 to the 4th. 3 to the 4th is 3 times 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27, times 3 is 81. And I think I may have written that one wrong. Did I? Oh, I did it to the 4th. I just realized that. Sorry. That one's a cubed because this one is a -3. So we changed the sign, not the number, -3 to a +3. 3 times 3 is 9, times 3 is 27. So that's your answer for 29(2). All right, then we've got 29(3). We have this one written as an exponential. We're going to change it to its reciprocal form. -3 to this negative will now be -3 to the +2. We say that that's the same as 1 over -3 times -3, which is going to be +9. So 29(3) is 1/9. Now, the next example, you're going to have to combine this with what you already know about the product rule for exponents, and it's printed in your book on page 122. Let's go ahead and combine these. Now, again, this is one big term. These are not multiple terms. There's no plus or minus signs. So we're not looking for like terms. This is multiplication. Let's multiply this times this. Okay? Now, I'm going to kind of write it longhand for a second. That's x to the 4th times x to the -2. I'm just going to put those together for a second just to help us see. And then let's put these together. That's going to be times m squared and m to the -5th. My commutative property says I can multiply these in any order I want, so I chose to rearrange them, to put them together. Now, when I multiply things that have the same base, I add the exponents. Here, same base, I'm going to add the exponents. Even though there's a negative in there, same rule. So this is going to be x to the 4 plus -2 is a +2. And m to the 2 plus -5 is -3. And we would just leave that in this form. But they want you to be able to use the rule you've learned in the past and be able to now use the same rule if you have negative exponents. Here's 29(5). All right, I'm not going to write it all out this time. We'll just underline it. X to the -2 and x to the 4. And here's an x. Don't lose it. What's its exponent? What's right here? Well, they don't write it. So you've got a 1. Don't forget about that. So I've got an x to the -2 plus 4. Negative 2 plus 4 would be a positive 2, plus this 1 would be a 3. Then I'm going to look at the y's. Here's a y, and here's a y. We've got a negative 6 plus a 5. So that's going to be y to the negative 1. Now let's deal with our z's. This z does not have an exponent written, but we know it's a 1. So that's going to be 1 plus 5, which is 6. So then your final answer for this is x cubed y to the negative 1, z to the 6th.